Greetings and welcome, friends. Mis amigos, mis compadres. Mr. Wadi and my algebra buddies are here. We were talking about standard deviation, which is a measure of how spread out our data is on average. How far each data point is from the mean on average, roughly, is what that represents. We had this crazy formula to calculate it. We take each data point, subtract the mean, right? We square those values. We add them all up and divide by how many there are. That's finding an average or a mean. And then we end up square rooting it, and we get a single number that represents roughly how far the data is from the mean, how spread out it is. So here's a data set. It says find the range and the standard deviation of the data set. So I have this data here. You guys can just follow along today. If I want to find the range actually isn't that tough to find. Actually, wait a minute, guys. Bad news, bears. There's no range formula here. So what I can do, find the range, is find the maximum number in the list, Jake, and subtract the minimum number in the list. And yeah, you might have been able to just look at that, but look at this. I can actually write a little formula in the spreadsheet, and bam, 25 is the range. Okay, so if I want to find the standard deviation, I'm going to do a full table this time just for funsies. So I'm going to find out what is X bar. So this is the average of the list. It's the mean, right? Add them all up, divide by how many there are. Hit enter, okay? So 47 is X bar. And I told you the other day that if you add dollar signs in front of the numbers of these cell locations, right, you guys tracking this? Because, right, you're going to need to know how to do this on the test. Right, I can lock that formula when I drag it down. So yeah, I need to do X minus X bar. So that's just going to be this cell minus that. So, right, so this data point was 7 units from the mean. Yeah. Variance is a number before standard deviation, square of the standard deviation. You'll see in a moment. It's when I average all of those together. Just see in a minute. So the next thing I do is I take X minus X bar and square it. Right? So I'm going to take these numbers and either multiply them by themselves. One way you could do it, right? Right? You guys tracking this? Or I can, right, raise it to the second power. Like so. Then what I would do is find variance, which, according to our formula, this is the step where I average, right, find the mean of the squared deviations. I'm doing. Okay? So I'm going to find now the average, figure out how far on average are these values from the middle. I get 86. Then the last thing I get is standard deviation, which is the square root, SQRT, of that. And I get a standard deviation of 9.27. There is a formula in Excel that can do this for you, STDEVP, if you happen to know the entire population, all of the data points, and we do. We didn't have a portion of the data here. You can put your cell phone away. And I get the same thing that way. So it does work the same way. So range tells you how spread out the data is by taking the highest number and subtracting the lowest number. Standard deviation finds out how spread out the data is by telling you how far on average point from the mean. Question, comment? Yeah, that's this one was X minus X bar squared. It just didn't fit in the cell. That's fine. So those are those values. Let's do the same thing with this one. It says find the standard deviation of golfer A and interpret your results. Do one of these by hand. So we'll do X bar. Let's see which question is. No, not that one. What number am I on? 23. All right, so X bar is like, yeah, I did have some of these out of sequence on purpose. Why aren't I changing these? Here we go. So X bar is when I find the average of the list. Find the average, 90. There we go. Right, average, you just add them all up and divide by how many there are. Then we'll have X minus X bar. So 83 minus 90 is -7. 84 minus 90, because this column's all the same. Which, by the way, on the test, you'll actually be doing this in the table. So 84 minus 90 is -6. 91 minus 90 is 1. 90 minus 90 is 0. This one's 8, 2, 5, -1, -3, and 5. So I get all of those values by taking the original data point, subtracting. Next thing I do is I square those, right? -7 squared, 9, 36, 1, 0. All right, so I'm just squaring these numbers. Remember that a negative number all squared will end up being positive. 1, 9, 5. And then we found the variance. You could call, right, it's just finding the mean again, except this time I'm finding the mean of this list. Tell you what, I'll do this on a calculadora. Listen to these awesome click-clacks as I type the keys. So I'm going to do 49 plus 36 plus 1 plus 0. Didn't need to type that one. Plus 64 plus 4 plus 25 plus 1 plus 9 plus 25. And I got 214 when I added those all together. But the question is, to find variance, I've got to now divide that by how many there are. How many we have? Is it 10? Yeah. Anyone know what that's going to be without me plugging it in the calculator? Yeah, you just shift that decimal place. Excellent. 21.4 is the variance. Yep. Yeah, I only have to do this. I don't have to fill the column. And sigma will be the square root of that. So I hit second square root button of second answer, and I got a standard deviation of 4.626. All right, so there's the standard deviation for golfer A. That means, on average, golfer A's scores vary from his average, his mean, by 4.6. Yeah. I will have the box set up, but I won't have the tops of them labeled. Oh, then now you've identified the thing you need to memorize and learn practice. Perfect. Perfect. I'll do golfer B using this over here. So X bar average of them, 91. Dollar those. X minus X bar. So that's when I take this one and subtract that one. I'll drag that formula down. This one's going to be X minus X bar square it, right? So that's just going to be that value squared. This is a different golfer. That's why these numbers are different. The variance is just going to be the average of this list. And then standard deviation is going to just be the root of that number. So I get 2.5. So 2.5 their sigma or standard deviation is. So in terms of interpreting these results, golfer B or right? Because on average, their score is a lot closer to their mean than golfer A's score was. Let's see, and their average was. So even though the mean was higher, which is worse in golf, they're more consistent at getting that mean than golfer A. All right. Let's see. Last question, 34. Yeah, flip it, flip it, flip it. There we go. It says the dot plots show the ages of members of 3 different adventure clubs. Without performing calculations, which data set has the greatest standard deviation? So of A, B, and C, which do you think has a greater standard deviation? Yeah, B. Right? Because it is spread out more. Right? And which is the least standard deviation? C. Right? Because it's compact. Right? It's densely located. I don't know if that's close enough. Located around the mean. Okay? So that's how kind of visually we could interpret standard deviation. And that's why when we even don't have a visual representation, when you get a standard deviation that is high or low, that's kind of what you should be thinking about. Like, okay, this data spread out. All right, thanks for watching, Internet friends. Have a great day.